My project concerns the essential notion of haptic feedback when users interact with objects in the virtual world. Starting off with this project, I researched the various existing solutions that tackle the problem of realistic haptic feedback. Most of these existing solutions focused on providing feedback through vibrations, without actually restricting movement to the user when touching a virtual wall, for example. Some of these existing solutions, though, focused exactly on restricting the user's finger movement by pulling the tips of the fingers. Such devices are also known as exoskeletons, and I was intrigued with the idea of restricting movement to the user's limbs, as it would definitely make virtual reality more realistic. The initial aim of my project was to create a haptic feedback device that would indeed be based on restricting the user's movement, just like an exoskeleton design. But an exoskeleton, as the name suggests, is based on the outside of the hand, whereas my idea was to place the exoskeleton design in the inside of the hand, more specifically on the palm. The palm, as opposed to the back of the hand, is filled with extra sensitive sensory cells, which in turn can be more accurate when feeling a shape and texture of an object. And since we use the palm in our everyday lives to distinguish between objects, I thought it would be a more natural medium for passing the notion of shape through my device. Here is a cardboard prototype of how my device could be implemented. The joints of my prototype could be adjusted using, for example, servo motors, which provide a very useful locking mechanism that would restrict movement of the user's fingers passing through the virtual object. The prototype also includes a padding mechanism that would support the fingers when the user closes his fist to grab an object, which can move freely with no restriction, as they would be responsible for giving the correct shape idea to the user. The main idea was to produce a mechanism that would shapeshift based on the shape of the virtual object the user grabs, while allowing completely free finger movement before reaching for a virtual object. When the user was to reach for a virtual object, the device, through signal from an Arduino processing board, would take the shape of the virtual object so that when the user grabs it, he would feel the exact shape of the object. Here are some of my design ideas I produced with drawings. They are all based on different designs, but they all follow the same idea of an exoskeleton design based in the inside of the hand. This is a design where a box-shaped device, including a matrix of linear actuators covered by a thin silicon membrane, that will be responsible for capturing the exact shape of the virtual object. While iteratively going through the design implementation evaluation cycle with my supervisor, when trying to conclude on the mechanism to be used to control and move the joints of my device, we stumbled upon an issue of whether this could actually be done. Therefore, the aim of my project slightly changed to answering this question: what is the impact of the number of contact points of a haptic feedback device on the finger of a user on the overall VR experience? Here, the direction of my project took a slight turn and should be reconstructed to fit this outline, meaning that the aim of my project is now to answer this question. Therefore, having a new project outline and the added aspect of comparison between the amount of contact points on the user's finger meant that my existing design ideas would need to be slightly altered to fit this outline. This means that in order to perform the required user test in the evaluation stage of my project, I would need to produce devices that provide 1, 2, 3 and full points of contact with the user's finger, and through feedback conclude on the impact that points of contact have on the virtual reality experience. In the next couple of weeks, here is what follows. 1. Decide on which mechanism and electronic component to be used in order to create the desired mechanisms, and which would be the best to show clearly the distinguishability of having different number of contact points with the fingers. By now, the best solution seems to be using a linear actuator and pushing on different parts of the finger, but linear actuators are expensive and quite large, which means I might be required to create my own version of linear actuators. Another possible mechanism is the one mentioned before, servo motors, which provide a locking mechanism that is needed when restricting movement is the main goal. Once the decision of mechanism to be used is finalized, I will move on to building these test devices, which should be challenging as I should create them in such a way that points of contact are distinct, and I will need to make sure that there are no external factors that will affect the test user's sense of feeling. Once the devices are built, I will use the Arduino processing board to connect either the linear actuators or servos to be used in order to be able to control them, and adjust their settings so that the devices can transfer correctly the sense of shape of a sphere, cube, or pyramid. I used Arduino before with servos, therefore it's not going to take much of my time. Finally, the devices are to be tested on real users, which will in turn be asked to answer a few questions, and based on the data collected, conclude on answering the main question of my project. Here is an example of the kind of questions I will be asking the test users. To end this video presentation, I would like to mention the complexity of building such devices. Various parts and components are required which are not available currently, meaning I will be required to 3D print them or laser cut them to produce these parts. Finally, my research and development so far seem to be minimal, but once the decision of mechanism to use in order to provide the haptic feedback is finalized, the project's development will speed up and be complete on time. Thank you very much.